the motion of a disturbance. Waves that require a material medium are called mechanical waves. Not all waves require a medium. Electromagnetic waves such as visible light, radio waves, microwaves, and X-rays can travel through a vacuum.
There are two types of waves, transverse and longitudinal. First, we'll talk about longitudinal waves, which are a wave whose particles are vibrating parallel to the direction of the motion of the wave. They are composed of alternating compressed and stretched particles. The compressed, as you can see in the slinky, are darker and closer together than the stretched particles that are lighter, as you can see now. Some common examples of longitudinal waves are sound waves and earthquakes.
A pulse wave is a single non-periodic disturbance. A periodic wave is a wave whose source is some form of periodic motion. So in a pulse wave, it creates one single wave, and in a periodic wave, it creates multiple waves.
Transverse waves are waves that move perpendicularly to the medium. A common example is a water wave. Think of a splash in a pool. The waves move up and down and move away from the origin.
A transverse wave is a wave whose particles vibrate perpendicularly to the direction of the wave motion. The wave will either move left or right as the particles move up and down. Therefore, the vibrations are perpendicular to the direction of the wave's motion. If you have ever seen a duck resting on top of the water and a wave passes by, you would notice that the duck moves up and down rather than side to side. This is because the duck acts as a particle rather than a wave. Try this at home. Get a slinky and a friend. Have your friend hold one end of the slinky stationary as you move the other end of the slinky left and right. Try changing the speed and see what happens. A transverse wave can be placed on a coordinate system. This is called a waveform. A waveform can represent either the displacement of each point of the wave at a single moment in time or the displacement of a single particle as time passes. This image shows the displacement in a single moment of time. The dotted line represents the equilibrium position, and the top blue line to the bottom blue line represent the displacement of each point of the wave at a time. The lowest point below the equilibrium position is called the trough. The highest point above the equilibrium position is called the crest. The maximum displacement from the equilibrium is known as the amplitude, or amp for short. And the distance from one crest to the next, or one trough to the next, is known as the wavelength.
Think about it. An earthquake causes a wave. Let me explain. The surface of the earth, which is represented by the bubble wrap, floats on top of liquid lava, or in this case, water. When we make a wave over here, it can impact what is on the other end of the Earth's surface, like these blocks which represent buildings. Watch what happens to the buildings when we make some waves. The waves knock the building over. Earthquake waves are called seismic waves, which can spread throughout the entire Earth's surface.
Wow, waves are cool, but wait, what would happen if a wave ran into something? Reflections are the result of a wave hitting another object. There are two types of reflections, fixed and free boundaries. In a fixed boundary, the wave hits something and is reverted and reflected. Like this. An example of this in real world is when sound hits a concrete wall. It echoes because the sound waves hit the wall and then bounce back. In a free boundary, waves are reflected but not inverted because it doesn't hit a hard surface. So it's free to move like this. This is what you would see on a flagpole when the wind is blowing.
When two waves travel together on the same plane, it is called interference. Interference can either be constructive or destructive. During constructive interference, the amplitudes of the two waves add together, resulting in a stronger and longer amplitude. Destructive interference is when two amplitudes oppose each other and therefore cancel each other out or weaken each other. Standing waves are a pattern that result when two waves with the same frequency, wavelength, and amplitude travel in opposite directions. Simply put, when two identical waves travel in the same plane in opposite directions, they create this pattern. They're composed of nodes, which are in the center, which is a point in a standing wave that always undergoes complete destructive interference, therefore it is stationary. This does not move, no matter how quickly the strings may vibrate or the waves may travel. This will always remain stationary because of the two opposing forces. And antinodes, which is when the trough or crest has the greatest amplitude. An antinode is a point in a standing wave halfway between two nodes, which is the largest part that occurs. There will always be more nodes than antinodes.
What are this? What are this? What are this? What are this?